Hey, Year 8s, let's take up Assessment 4. This first question is an equations of lines question again, and what we need to remember about the equations of lines is that we need to know two things. We need to know what their y-intercept is, which is just where that line crosses the y-axis here. That should be the easiest thing to figure out. This one crosses at 3, this one crosses at 1, this one crosses at -1, and the other thing's a little bit harder. We need to work out what the gradient is. At least I can see that this has got a positive gradient because it's going upwards, whereas this blue one's got a negative gradient, it's going downwards. And this red one isn't going up or down, that's got a 0 gradient. So it's just got that y-intercept, that's the only defining feature of this line. Y is equal to 3. Oh, I just gave it away. The red line, the equation of the red line is a horizontal line, and it's y equals 3, because every point on that line has got a y value of 3. The blue line, as we mentioned before, is this downward sloping line, so it's got a negative gradient and a y-intercept at 1. So we're looking for an equation of a line where it's got y equals some negative number of x plus 1. Now I'm looking at my equations here. That's a positive gradient. That's not a very big positive gradient, but it's a positive gradient. That one was our straight horizontal line. That's got a positive gradient. This one's got a negative gradient. Is it the only one? Yes, this one's got a positive gradient, positive x, and this one is just x equals 3. That would be a vertical line. So like this, x is 3, vertical line. So the one we're looking for, the blue line, is the only negative gradient one I see. It's this one. And let's just double check that with the graph. This blue line on the graph has got a y-intercept of positive 1. That's why we see plus 1 as the y-intercept. And its gradient, its steepness, is -1, because if I go out one step, I have to fall down one step. So it's going down every time I take a step out to the right. I go out to the right, and I fall down 1. Every step out to the right I do, I fall down 1. So it's a -1 gradient, because I'm always falling down 1. The next one's the green line, and as we said, that's this line here, which has got a y-intercept of -1. And it's going upwards. It's going up quite steeply. So let's look for a positive sloping line with a y-intercept of -1. Don't even bother with this one. This has got a y-intercept of +1, and I want a y-intercept of -1. This one's got a y-intercept of -1, but as we mentioned before, that's not a very big number. That's not very steep. We'll keep it in mind just in case, though. It's not this one. Could it be this one? It's got a y-intercept of -1. And it's got a gradient of +2. It's going up in 2s. I'll come back to that one again, just in case there's another one here that I might consider. Not this one. This one's a positive sloping line. It's got a y-intercept of -1, so maybe it's this one. Although between the two of these, we should hopefully see that this is the steeper one. And it's definitely not that one. As we said, that one was a vertical line. Okay, so let's go back to our green line here and figure out what this gradient is. Every time I take one step out to the right, I have to climb up 2. Up 2, that's +2. Every step out to the right, I go up 2. That's a positive gradient of 2. Every step out to the right I go, I have to go up 2. So we need to find the equation of a line with a y-intercept of -1 and a gradient of +2, which we found over here. Y-intercept of -1 and a +2 in front of the x. That's a gradient of +2. There we go. Okay, linear sequences and the nth term. Here again we've got a linear sequence. It's a number pattern which has got a common difference. It's always going up by the same amount, this one. Do you see what it's going up by? 8, 12, 16, 20, 24. It's going up by 4s. So my nth term rule is going to be t equals the force times table, so 4n, but this is not the force timetable. Although these numbers are all in the force timetable, it doesn't start with the first number in the force timetable. It starts with an 8 instead of a 4. That's 4 higher than the force times table. So I would do for the first term, t is equal to 4 times 1, which is just 4. I need to add my adjustment, which is 4. For the first term, 4 times 1 is 4 plus 4 would make 8. For the second term, 4 times 2 would make 8 plus the 4 makes 12. So that's what my adjustment was. That's my formula. T equals 4n plus 4. And I'm going to use that formula to answer these questions as well. Work out the 13th term of this sequence. Well, I've just worked out the rule was t equals 4n plus 4. The 13th term will be the term when n is equal to 13. So I'll use that rule. T is equal to 4 times 13 plus 4. I've just replaced the n with the position number that we're looking at. We're looking at the 13th term, the 13th position. I replace the n with 13. That's going to be 4 times 13, that's 52, plus 4, which is 56. So the 13th term in this sequence, you could continue it if you like. It'll take you quite a while though, just adding 4, adding 4, adding 4, till you get to the number 56. That's the 13th term. Now I wouldn't continue this pattern until I found the 100th term. That would take me the entire necessary time for the assessment. But don't want to waste time like that. Let's use the rule. T equals 4n plus 4. For the 100th term, we're talking about position number 100. I'm going to replace the n with 100. So t equals 4 times 100. See, I just replaced the n plus 4. 4 times 100 is 400, so this is 400 plus 4, and that's 404. 404. Right, let's move on. Angle theory. Now, be careful. There's a lot of assumptions being made on these questions here, and we need to be careful. I didn't put any markings on these lines here. I didn't tell you that they were parallel. And yet I'll bet a lot of you use parallel line theory to work out the missing angles. What we definitely do see is two lines which cross another line. So let's just use the fact that they are straight lines, because they are straight lines, that we can see. Even though it's not to scale, they are straight lines. So to work out angle A, we could say A plus 122 equals 180, because that is a straight line. This blue line here, at this point here, has two angles on this side of it, which need to add to 180. Okay, so A must be equal to 180 minus the 122, which is 58. So there I can say, yes, A is definitely 58, because I know this is a straight line, for no other reason. A equals 58. Okay, for B, now I can see that this is a straight line that crosses this straight line, and I see that A and B sit across from each other. They are vertically opposite angles, and vertically opposite angles are equal. So I've just written that. I've got my rule here. B is equal to A with its explanation. They're vertically opposite, and I already know what A is. It's 58, so B is equal to 58. No more working needed. I just explained why I did that. So they're vertically opposite. B is 58. A is 58. What's C? Is C 58 too? No. Let's use this diagram, and the only thing we know is that this here is also a straight line that's being cut by this straight line. And I see these 2 points, or 2 angles, sorry, on the same side of this blue line. So they should add to make 180, because that's a straight line. C plus 58 equals 180, so C on its own should be 180 minus 58. That makes 122. Now, can we be sure that these two blue lines are parallel? Before, as I said, I never told you that they were parallel. I didn't show you with arrows, and I didn't explain it in the question. But after all this working that we did, and I didn't use the fact that they might be parallel lines in my working, all I used was the fact that they're straight lines or vertically opposite. But now I see that if they are parallel lines, they should make an F pattern. A should be corresponding with 58, so they should be the same. And they are. Also, I see a C pattern here with B and C. So those are interior angles, and they should add to 180. B is 58, C is 122. That adds to 180. Sounds like it's working pretty well so far. Also, if this line is parallel to this line, then C and the 120 degrees also make an F pattern. They would be corresponding. And if they're corresponding, they should be equal. And C is equal to 122. So with all of those rules working out nicely for me, yes, I am sure that these blue lines are parallel. Yes. Now this example looks very similar to the previous one, but it is not the same. Study the diagram carefully. It's not to scale, and I didn't mention that they are parallel lines. They may look parallel, but I never said it, and there might be some values there that prove that it is or is not. So let's have a close look at this. Again, we're not making any assumptions that they are parallel. The only thing that we can assume is that this is 3 lines, one line that crosses through the other 2. Okay, so looking at angle X, once again I see that this is a straight line, and these 2 angles on the same side of that straight line should add to 180. So x plus 142 equals 180. So x equals 180 minus the 142. That's just to get the x on its own. Working out what that is, x must be equal to 38. Oh, that should say x there, sorry. Okay, so x equals 38. Now let's look at y. Again, I'm not going to make any assumptions about the angle y and this 142 degrees because I don't know if these lines are parallel or not. What I do know is that y is lying on a straight line with the other angle 42. So I could say they add to 180 because it's a straight line. So to get y on its own, I'll say y equals, taking the 42 to the other side, 180 minus 42. And that is 138. It's not the same thing as this 142 here. This is 138. And z. Okay, again, no assumptions about parallel lines here, but I've got one line which crosses another line, and I hope you remember what that's called when these are across from each other on a cross. They are called vertically opposite and they are equal. So z is equal to y, and y being 138, that means that z is also 138. Now, are the green lines parallel? I've been hinting at this since the beginning. If they were parallel, the 42-degree angle and the x angle, they should be corresponding in this F pattern here. And if they're corresponding, they should be equal. But x is 38, not 42. So I don't think these lines are parallel. Also, y and the 142 should be corresponding in another F pattern. And they're not. Y is 138. So no. I definitely don't think that these are parallel lines. No. Now some more angle theory. Again, you need to look carefully at the diagram. It may not be drawn to scale, but I did warn you up here. Look at the markings on the lines. What do these markings mean? I even warned you by making the first question, what kind of triangle is the red triangle? And most of you got that right. However, the correct answer is that it's an equilateral triangle. Some of you put regular, and you really need to learn the word equilateral. In future, I'm only going to accept equilateral or equilateral triangle. So make sure you got that right next time. Now, what kind of triangle is the blue triangle? Some people looked at this and they didn't see it as being any special kind of triangle at all. You could say it's an obtuse triangle, but more specifically, it's an obtuse isosceles triangle. It's got 2 equal sides, and that's going to help us with the angles as well, because isosceles triangles have 2 equal sides and 2 equal angles. So that was all meant to help you, as very often these multiple part questions are. So now let's work out angles A, B, and C. Angle A is an angle inside this equilateral triangle. I know you know it's equilateral, I just asked you. So equilateral triangles have all angles equal. All of those angles will be A. So that means that there are 3 angle A's that need to add to make 180. Or A on its own is 180 divided by 3, which means A is 60. So A is 60 degrees. To work out angle B, I can see that A and B lie together at this point on this straight line. So this angle here adds with the angle B to make a straight line, to make 180 degrees. A plus B equals 180. So write your equation, explain it with a rule. And now let's solve this equation. There are 2 letters I don't know here, but I've already worked out one of them. A is 60, so this is 60 plus B is 180, which means B on its own is 180 minus the 60. So B must be equal to 120. Let's fill that in. Finally, C. Remember that you know what kind of triangle this is. Even though I haven't labeled this angle up here at the top, you know that two of the angles on this triangle are equal. And I hope you don't think it's these two. The two angles that sit on the equal sized lines, but not between them. So this is the different angle. But we know that all three of these angles of any triangle adds 180. So B plus C equals 180. I see that there are two angle C's here. So let's replace the B with the value we know and simplify that a bit. B is 120 and C plus C, that's two C's, and all together that makes 180 because this is a triangle. Rearranging that to get C on its own, two C's would be equal to 180 minus the 120. It was plus on the other side, now it's minus. So C must be equal to 180 minus 120 was 60, so C is 60 divided by 2, which is 30. So filling that in. Now, this last question may have confused some of you. Together, what kind of triangle does this make? True or false? The red and blue triangle together make a right angle triangle. Well, this is definitely not a right angle. This is part of the equilateral triangle, and we know that that's 30 degrees. So 60 degrees. We worked out this angle here, and we worked out that was 30 degrees. Now, this angle here at the top, could that be 90? We know that this is 60, and we know that this is 30. 60 plus 30, yep, that's 90, so this is true. Last question, this is an isosceles trapezium. Now, just like an isosceles triangle, isosceles trapeziums have two sides which are equal to each other, but more than just that, just like an isosceles triangle, they have symmetry, a line of symmetry down the center, which means not only do they have equal sides, they have some equal angles. I labeled B and B on here to make that clear for you. Those are the same angle. But also down here, you may not be able to work out what A is on this side. However, it will be equal to the angle over here on this side. So I'll label that angle A as well. Now, I can't really work out this A, but I should sure be able to work out that A. A and 250 degrees outside should add together to make a full turn. That's 360 degrees. A plus 250 equals 360. So A by itself should equal to 360 minus the 250. So A must be equal to 110. Now work out the value of B. Again, this is a bit more work, but we certainly know something about this shape. Apart from the fact that it has symmetry, we also know that it is a type of quadrilateral, and the angles of a quadrilateral always add to 360. So that means that A plus B plus B equals 360, because it's a quadrilateral. Now we just worked out what the value of A was. A is 110, so that means this is 110 plus 110 plus, I've grouped my two B's together, so that makes 2B, and that makes 220 plus 2B equals 360. Now to find out what B is, I want B on its own. I'm going to move the 220 to the other side. On this side it's plus, so that side is minus. 2B equals 360 minus 220, which means B is equal to 140 divided by 2. Because the 360 minus the 220 was 140. 140 divided by 2 is 7, so B must be 70. Okay, well done, guys.